Well, I just saw that last video and I have to apologize. I'm kind of rambling because I'm getting sleepy. I'm going to try to keep it more to the point. Study goal number 26 we've already talked about. That was the dissolved oxygen BOD diagram that was on the whiteboard. Study goal 27 was the warm-up yesterday. You know that coliform bacteria comes from the gut. That's basically poo. And you know that they do best in anaerobic conditions. Extra nutrients are basically fertilizer for them. Extra organic material and sediment is the food that they need. So the problem with canals, I think you understand, they get fertilized by all of those dissolved nutrients. They thrive in anaerobic environments because canals have very low dissolved oxygen. And they get to eat a lot because there's tons of suspended organic sediment in canals. Okay, that was number 27 about coliform bacteria. Number 28 gets a couple of stars, and I'm going to try to keep this direct, but it's probably the last major issue in this unit. Today's warm-up. All life needs nutrients. How can nutrients be pollution? Remember that if you dump a lot of nutrients into water, that is not itself pollution. The nutrients when they when they're added to an ecosystem, they are fertilizer. They make more life. Everybody's happy. Everybody knows that if you bring more supplies to the party just gets better. When the supplies run out, that's the problem. Nobody wants to stick around because everybody knows the worst part of the party is cleaning up afterward. So eutrophication is a problem because here comes your sequence for your notes. Surge in nutrients, burst of life, so far not a problem. But when the nutrients taper off, then all that new life starves. And when you have a bunch of dying algae in the ocean, remember that that's biodegradable. The decomposers use up all the oxygen. And the last thing you'll need in the notes after the decomposition oxygen there is that dead zones are places in the ocean where nutrients have spiked and then dropped off. So a bunch of new life was created and then died, and in its decomposing, oxygen levels have dropped. If you could look over here, you see the Mississippi Basin? Everybody knows where the Mississippi Basin is. It's like the big yellow and green streak in the middle of the United States. Goes almost all the way up to Canada there. Think of what's happening up there. We have a bunch of cities and a bunch of farms. So we are taking water out of the ground, pouring it onto farms, and runoff is being added to the rivers. Nutrients are accumulating on land. Every one of the cities on those rivers is adding their wastewater and their runoff. At the end of the rainy season, when that entire yellow-green basin gets washed into the Gulf of Mexico, you have a dramatic spike in nutrient flows. The Gulf of Mexico at the end of the rainy season is the world's largest dead spot in any of the oceans. I pulled down that map today because you can see over there Oregon, Washington, the Columbia River, California Central Valley at San Francisco Bay, the Sea of Cortez draining the Colorado River, the giant Mississippi River Basin in the middle of the United States, and a couple that I can't remember the names of on the East Coast. One near the Carolinas and one near Maryland or something. Where those rivers go out to the ocean, any spike in flow usually corresponds to a spike in runoff, which means a spike in nutrients, okay? Dissolved nutrients. Everybody remembers that. The nutrients themselves are not a problem per se. It's the fact that they will run out. The supplies will be done. All the fresh life will starve and die. And when you've added a lot of decomposing material to the ocean, everybody understands that its decomposition uses up oxygen and stuff dies. In the biggest dead zone on the planet, the one in the Gulf of Mexico, we're talking some hundreds or thousands of square miles of critically low dissolved oxygen levels, huge impact on fisheries, massive die-offs. To a lesser degree on the Pacific and Atlantic Oceans, there are others. Internationally, there are others. Really easy alternative, you can solve this plain old wetlands to soak up those nutrients. That's what wetlands like to do. If we hadn't lost so many of America's wetlands, we could probably keep doing a lot of our same terrestrial land use with our same terrestrial water use and still be okay. It's really the combined problem of extra irrigation that makes more runoff with more nutrients added on land. That's the problem of our land use. Plus, you couple that with the fact that we channelize that into water, and then we don't have the wetlands to slow down, absorb, and bioremedy that water. So when it hits the ocean, it's what we saw in our little Mission Creek times a million. Mission Creek times a million. Think of all of those nutrients, how much life that will fertilize, that's the good part, and then when everything dies, how much oxygen it'll take out of the water to decompose that burst of life. After that spike in runoff, the spike must go down, and when it does, there's that big die-off that decomposes. Okay. This is how eutrophication, people call it cultural eutrophication, to separate away from what's called natural eutrophication. Natural rainfall patterns cause natural changes in nutrient levels. This is a natural process. But all the stuff that humans add to the problem is called cultural eutrophication. I'll write this on the board so by tomorrow eutrophication will be written up there. This is the problem. Too many nutrients, the die-off afterward uses up all the oxygen. You get dead zones, big one in the Gulf of Mexico. That's study goal number 28. This is especially bad in lakes and oceans. In lakes, though, a lot of times the issue is algae floating on the surface blocks light, so oxygen isn't being made down below. Slightly different issue, that in lakes, the boom in productivity is often floating. Since there's only oxygen on top, most of the life is always on top in lakes. So in lakes, you get an algae mat that blocks the sunlight and kills the oxygen producers down below. But anyway, extra nutrients, that's the lake type, algae mat, and the ocean type, dead zones. Probably write that down. Lake type, algae mats, ocean type, dead zones. That was a little shorter. I did a few more study goals. I'm going to take another break. We'll come back to skim just a few more, and then we'll get to the stars soon.